20 centimeters cube of ethanoic acid was diluted to 400 centimeters cube of solution. Calculate the concentration of solution in moles per liter. Carbon is equal to that, or that the density of ethanoic acid is 51.05 grams per centimeter cube. So that's where we begin. So it means that 1.05 grams is equal to 1 centimeters cube. So we will find out 20 centimeters cube of ethanoic acid will contain how many mass? 20 times is 1.05. So we will find that it has 21 grams. The one that was used is 21 grams of 20 centimeters cube ethanoic acid. Moles of 20 centimeters cube ethanoic acid. So first we need to know how ethanoic acid is written. How do we write ethanoic? Ethanoic acid is CH3COOH. So this one we add 12 plus 3 plus 12 plus 32 plus 1. And this one will give us 60. So 60. So the RFM of the ethanoic acid is 60. So now moles we know is equal to mass, which is 21 over 60, which is the RFM, and this one will give us 0.35 moles. So moles of ethanoic acid in 20 centimeters, so 20 centimeters cube of the original before dilution. Remember it was diluted to 400. Original is equal to 0.20 original moles yake ni 0.35. So moles in 400 itakuwa ngapi? When you dilute a solution, moles does not change. Therefore, moles in 20 centimeters cube ethanoic will be equal to moles in 400 centimeters cube, even if it is a derivative. What changes is the concentration and not the number of moles. So now 400 centimeters cube contains 0.35 moles. We are told the concentration is in moles per liter, moles in 1,000. We will ask 1,000 centimeters cube will contain how many? So it is 1,000 times 0.35 divided by 400. This one will give us 0.875. So for you to understand what we are doing here, let me give you an example. Let me use Kiswahili for you to understand. Uchukue kijiko moja. This is my pen. Kijiko moja. Assume hii ni kijiko. Kijiko moja niweke ndani ya maji kwa glass. Tunaelewana? Si nimeweka kijiko moja. Alafu hii maji nikoroge. Nichukue hii maji yenye iko kwa glass ni transfer niweke kwa 20 liters. Alafu niongeze maji kwa 20 liters mpaka ijae. Nikuulize, the number of moles ya sukari yenye iko kwa yenye ilikuwa kwa maji ya glass na yenye iko kwa 20 liters, is it different? It will not be different, it will be the same. Kwa sababu sukari ni ile kijiko moja niliweka. Kwa hivyo moles ya hiyo sukari yenye niliweka itakuwa the same hata kama nimedilute. Moles remains the same, concentration the changes. Hii yenye niko kwa glass moja nikiramba hivi nasikia utamu wa sukari. Lakini hii nimedilute mpaka imekuwa 20 liters, siwezi sikia hata kama kuna sukari ndani because it has. So kitu when you dilute, so kitu imechange ni concentration. When diluting a solution, the number of moles remains the same, the concentration changes. calculated the mass of nitrogen 4 oxide gas that would occupy the same volume as 10 grams of hydrogen gas at the same temperature and pressure. So what we are given is the mass of hydrogen. So we can get the moles of hydrogen. Moles is equal to mass over Fm. The mass for hydrogen, that is moles of hydrogen, itakuwa ni 10 grams divided by RFM. RFM of hydrogen is 2. So this one gives us 5 moles. So nitrogen 4 will have the same, because it is the same volume, so we'll have the same number of moles. We'll have 5 moles because they have the same volume. Therefore, we are asked the mass of nitrogen 4 oxide. But we know mass is equal to moles times RFM. So let us get the RFM of nitrogen 4. So nitrogen 4 is 0.2. So this one is going to be 14 plus 16 times 2. And the RFM is going to be 46. That is 46. Then it means that mass of nitrogen itakuwa ni 46 times 5. And this one will be 230 grams. 230 grams. The 0.63 grams of lead powder were dissolved in excess nitric acid to form lead nitrate solution, or the lead nitrate solution was reacted with sodium sulfate solution. Write an ionic equation for the reaction between lead nitrate and the sodium sulfate solution. Write ionic reaction, ionic. So before I write ionic, let me write the reaction that took place, the general reaction. So this is lead nitrate reacting with sodium sulfate. So this one is a double decomposition reaction. They will interchange the anions. These both of them are aqueous. They will interchange the anions, forming an insoluble salt, which is lead sulfate, plus sodium nitrate. So what happens here is that the metal here takes the cation here takes the anion this side, and the anion this side combines with the cation this side. That's what happens here. So this one is a solid and this one is an aqueous, because all nitrates are soluble. So once you have written like this, you are supposed to rewrite this equation ionically. So you will say lead 2 positive plus 2 nitrates minus plus sodium positive, which is 2 of them here, plus the sulfate 2 minus will give us, this one remains lead sulfate, because if it is in solid form, liquid form and gaseous form, you don't write the ionic for that. If it is in liquid, gas or solid, you don't touch it ionically, it just remains. Then this one, as you can see, it is aqueous, therefore it will form 2Na positive plus 2NO3 minus. So they are the ions you are seeing on the left side, and they are appearing at the same time on the right side. Those are called spectator ions. They cancel out. They have no importance there. So the spectator ions, as you can see here, we have sodium to sodium to sodium, nitrate to nitrates to nitrates. So those are called spectator ions. So what remains now is lead to positive, which is in aqueous state, plus the sulfate ion to minus aqueous state, and this one forms lead sulfate solid, and this is the ionic equation. That is the ionic equation. So for example, I can do a more example on the same. If you are given, for example, barium nitrate plus sodium sulfate, this one will form barium sulfate plus sodium nitrate, two of them. So ni muhimu sana kujua kuandika the aqueous AQ solid liquid. Unajua aje? Yasema huo umeelewa what we call solubility of salts, the solubility. So this one is aqueous, this one is aqueous, this one is S, this one is aqueous. Now simply you write the ions which forms the solid only. So you just write here barium ions, aqueous, plus the sulfate, aqueous, which will form barium sulfate solid, and this is the ionic equation. So once you have understood, you can simply write, you only write the ions which forms the solid, that's all, or the ions which forms the liquid, that's all, and you are done writing the ionic equation. Determine the mass of lead salt in A above. The mass of lead salt in A above. So let us get the mass of lead in A above, the mass of lead. Lead that was used, we need to get the information from the question. So mark it down that we were told that 0.63 lead. So 0.63 lead were used. And from the equation, as you can see, the ratio is 1:1 everywhere. So the ratio is 1:1. The lead sulfate that was formed and the number of moles of lead will be equal to the number of moles of the lead sulfate that was formed. You need to know that. So we need to now calculate the mass of lead, the moles. So moles of lead is equal to mass over Fm. But this is zinc, this is RAM. Now this one will be equal to 0.63. We divide by 207 because the RAM is 207. This one gives us 0.003 moles. So we are asked to find the mass of the salt that was formed. The salt that was formed is lead sulfate. So first let us get the RFM of lead sulfate. So RFM of lead sulfate itakuwa ni, this is 207 plus 32 plus 16 times 4. This one will give us 303. So 303 is the RFM of lead sulfate. But how do you calculate mass of a substance? So mass is equal to RFM times moles. So the mass will be equal to 303 times the number of moles, which is 0.03. Why did we use 0.03? Because the number of moles of lead will be equal to the number of moles of the salt that was formed. So this one gives us 0.922 grams. On complete combustion of a sample of hydrocarbon, 3.52 grams of carbon dioxide and 1.44 grams of water was formed. Determine the molecular formula of the hydrocarbon. Relative molecular mass is that 56, carbon 4 is that, and those we have been given all those. So you see, an hydrocarbon is a compound that is made up of hydrogen and carbon only. You need to know that. That definition is very important. So from here, if 3.52 carbon 4 oxide was formed, from here we just need carbon. And then 1.44 grams of water was formed. From here we just need hydrogen, because an hydrocarbon contains carbon, and hydrocarbon contains carbon and hydrogen only. So we start by calculating the mass of carbon. So mass of carbon will be equal to carbon inside in this carbon dioxide is 12 kwa sababu ni moja, divided by the total, which is 44. We multiply by 3.52, and this one will give us 0.96 grams. That is carbon. Then mass of hydrogen. Mass of hydrogen inside here itakuwa, kwa sababu ukiangalia water iko na hydrogen mbili, so it's going to be 2 over the total molecular mass, which is 18, times the total mass, which is 1.44. We will get 0.16 grams. So once we have that, since now we have the mass, now we can calculate the empirical formula. We can write element. Now we have now the mass of each element. Now we can calculate the empirical formula of, we know how to do that. Element, we have two elements, carbon and hydrogen. So mass in grams, carbon is 0. Hapa tumepata 0.96, hydrogen is 0.16. Next is RAM. For carbon is 12, for hydrogen is 1. And then next is moles. Moles here, you divide by this one is going to be 0.08, and this one is going to be 0.16. Next is the mole ratio. Mole ratio you divide by the number of moles that is least. So the number of moles here least is this one. 0.08 divided by 0.08 is 1, and this one is 2, meaning that the empirical formula is going to be CH2. That is the empirical formula. But the question was asking us to calculate the molecular formula. You can see here, calculate, determine the molecular formula. So now we have the empirical formula. CH2 times N will give us 56, the molecular mass. We were given in the upper. The molecular mass is that 56. So this is 12 plus 2 hydrogen, that is 2. N will be 56. So 14N is equal to 56 divided by 14. So N is equal to 4. Then the molecular formula will be CH2 times 4. And this one gives us C4H8. And that is the molecular formula. The empirical formula of lead-2 oxide was determined by passing excess dry hydrogen gas over 6.69 grams of heated lead-2 oxide. What was the purpose of using excess dry hydrogen gas? What was that? Is to ensure that all lead-2 oxide is reduced to lead. To ensure that all the lead-2 oxide is reduced to lead metal, in order to obtain the correct empirical formula. The mass of lead was found to be this, determining the empirical formula of the oxide. So remember, initially the lead-2 oxide mass yake yenye iliwekwa ilikuwa 6.69 grams. So the mass of lead was found to be 6.21 after reduction. So meaning the mass of oxygen was this minus this, and I think this one is going to give us 0.48 grams. So now we write element. Our element is lead, oxygen. Mass in grams. This one will require 6.21. This one is 0.48. Next is RAM. Lead we have been given 207. Oxygen is 16, we know that. Next is the number of moles. Moles is mass over AM, which is 0.03, and this one is 0.03. So mole ratio is 1:1. Then now the empirical formula is lead oxide. In an experiment, 2.4 grams of sulfur was obtained by reacting hydrogen sulfide and chlorine as shown. Which of the reactant acts as a reducing agent in the above reaction? So to know that, you need to find the oxidation numbers of each species that is reacting. So let us rewrite this equation here so that we can calculate the oxidation number of each. So the oxidation number of sulfur here, the oxidation number of sulfur there is -2. So sulfur here is -2. Chlorine here is 0 because chlorine is a gas, so all elements and the molecules are 0. Oxidation number 0. Sulfur is 0 here, and the chlorine here, the chloride ion here is actually -1. So how do you know? If you want to know oxidation number for this one, for sulfur, you say X plus hydrogen in moja, so 1 times 2, 2 will be equal to 0. So X is equal to -2. Hii ikifuka pande hii itakuwa -2, so ndio maana tumepata hii. This one is 0. If you want for chlorine here, you say 1 plus X is equal to 0. So X is equal to -1. Ndio maana hapa -1. So you can see hydrogen sulfide, the oxidation for hydrogen sulfide increased from -2 to 0. That's an increase. So that means this is oxidation. Then chlorine, we can see the oxidation number moved from 0 to -1. Is that an increase or a decrease? That one is a decrease. So this is a reduction. The species which undergoes oxidation, you need to know. The one which undergoes oxidation is the reducing agent. The species which undergoes reduction is the I've said the species which undergoes oxidation is the reducing agent. The species which undergoes reduction is the oxidizing agent. So I hope I have explained this one. Now we are going to answer the question. So to answer the question, hydrogen sulfide is the reducing agent. Is the reducing agent. Reason? This is because oxidation number of sulfur increased from -2 to 0, and that is the reason. Given that the yield for sulfur in the above reaction is 75%, calculate the number of moles of hydrogen sulfide gas used in the reaction. So first let us get 100%. What is the mass for 100%? Because 75% inatupea 2.4 yenye ilitumika. What about 100%? So 100 times 24, 2.4, sorry, 75. This one will give us 3.2 grams. So 100% is 3.2 grams. So let us find the moles of sulfur. What we are using, the information we were given here, that 2.4 of sulfur. So now we are going to calculate the mass, the moles of sulfur, because now we have the RAM of sulfur, which is 32, which is 3.2, the total mass. Now moles of sulfur is equal to mass over RFM, and that is 3.2 over 32. So it means moles is 0.1. So the moles of sulfur is 0.1. From the equation, again, if I take you back, the mole ratio for sulfur and hydrogen sulfide is 1:1. You can see, so the meaning that the moles of sulfur will be equal to the moles of hydrogen sulfide. Having that in mind, we will say that moles of hydrogen sulfide will be equal to the moles of sulfur is equal to 0.1 moles, because they have the ratio is 1:1. So moles of hydrogen sulfide is equal to 0.1. Hiyo ndio tuliulizwa moles of that. Zinc, metal, and hydrochloric acid react according to the following equation, and this is the equation, a well-balanced equation. 1.96 of zinc metal were reacted with 100 centimeters cube of 0.2 molar as the acid. Determine the reagent that was in excess. Zinc metal and hydrochloric acid react according to the following equation. This is the equation which has been balanced. 1.96 grams of zinc metal were reacted with 100 centimeters cube of 0.2 molar hydrochloric acid. Determine the reagent that was in excess. So for you to determine the reagent that was in excess, first let us get the number of moles of what we know. We are sure of this. 0.2 capital M means, implies that the 0.2 is the number of moles which are contained in 1,000 centimeters cube of HCl. So we will find out 100 centimeters cube of HCl will contain how many moles. So that one will be 0.2 times 100 divided by 1,000. So this and this, this and this. So moles, we will have 0.02 moles of HCl. What is the relationship between HCl and zinc? The mole ratio is 2:1. So there is 1 here. So 2 moles of HCl reacted with 1 mole of zinc. If that is the case, then we can write here that mole ratio is equal to zinc to HCl ni 1:2, lakini moles ya HCl ni 0.02. So what will be the number of moles of zinc? That one is simple now. You just multiply 0.02 times 1 divided by 2. So moles of zinc is equal to 0.01. So now this one will give us the number of moles of zinc that reacted with 100 centimeters cube of HCl. Now we can, the next thing we want to look at is what was the number of moles of the original mass that was there. So mass of original zinc itakuwa ni, we know the mass we were given ni 1.96. So what will be the moles? Moles is equal to mass over RAM, and that one is 1.96. We divide by RM of zinc, we tumepewa ni 65.4. That is the RM of zinc. So this one, when you divide by, you realize that it is going to give us 0.03 moles. So initially the number of moles was of zinc was 0.03, but that reacted with HCl is 0.02. Now which one was? So it means that the zinc was in excess by how many moles? By, that is 0.03 minus 0.01, so by 0.02. Therefore it means that the zinc was in excess. You can give reason since 0.02 moles of HCl only reacted with 0.01 moles of zinc, remaining how many? Remaining 0.02 more. Yeah, 0.0 more remained because the total was 0.03. Now you have proved that zinc was in excess. You have shown that zinc was in excess. Calculate the total volume of hydrogen gas that was liberated at STP. Calculate the total volume of hydrogen gas that was liberated or produced at STP. We have been given this in bracket. So we need to know that 1 mole of any gas, but in this case we have hydrogen, at STP is equal to this volume that we have been given here, 2.4 liters or dm cube. Now we want to know the number of moles of hydrogen that reacted. How do you know that? You go back to the equation and we try to look at the relationship. Hydrogen is here. So this is our hydrogen. This is the hydrogen. So the mole ratio here, as you can see, is 1. As that it looks, it is the same as that of zinc. So zinc, the number of moles of zinc was 0.01. It means the number of moles of hydrogen is also 0.01 because the ratio is 1:1. So if that is the case, then we will now say 0.01 moles of hydrogen will contain which volume. So this is 0.01 times 22.4 divided by 1, divided by this one. This one will give us 0.224 liters. You can convert these liters into centimeters cube. So that is, you multiply times 1,000. That one will be 22. We repeat 22. 224 centimeters cube. A compound has an empirical formula C3H6 and O, and the relative molecular mass is 116. Determine its molecular formula. Hydrogen is that we have been given the RAM of each. So one thing we need to know is that the empirical formula times a number n will be equal to molecular mass. So our empirical formula is C3H6O times n, where n is a number can be 0, 1, 2, 3, or that, times n will give us the molecular mass, and the molecular mass, the relative formula mass is 116. Molecular mass is the same as relative formula mass, so there's no big difference. So, and then carbon, we have been told it is 12. So how many carbon atoms are? So this is 12 times 3 plus hydrogen 1. Hydrogen is 1 times 6 of them plus oxygen is 16. So everything here times n will give us 116. So when we do this multiplication, that is 12, this is 12, 36, that's 7, that's 6, 42 plus this one gives us 58. So 58 n will be equal to 116. So divided by 58, n is equal to 2. So if now we want the molecular formula, we multiply the empirical formula times the value of n that we have obtained. So C3H6 O, we multiply times 2, and this one will give us C6H12 oxygen 2, and that is the molecular formula. The molecular formula of that organic compound. Calculate the percentage composition of carbon by mass in the compound. So the compound we have obtained is C12C6H12O2. So what is this one? When you add everything here, it will give us 116. So the total molecular mass is 116. But we want the percentage for carbon alone. So carbon atoms, there are 6 of them. So 12 times 6, you divide by the total, which is 116, times 100, it will give us the percent. So 12 times 6 is 72 over 100, then times 100, divided by 116, the total molecular mass, times 100. This one will give us 62.02%. Calculate the amount of calcium carbonate that would remain if 15 grams of calcium carbonate were reacted with 0.2 moles of hydrochloric acid. The equation for the reaction is as shown below. So you can see our equation here. So we need to get the number of moles of calcium carbonate that reacted with 2 moles of hydrochloric acid. We have the number of moles of HCl. So number of moles of HCl tumepewa ni 0.2 moles. That is enough. But the mole ratio for HCl and the calcium carbonate, you can see the mole ratio here is 2, here is 1. There is 1 here, which is not put there. So the mole ratio, that is the carbonate to the acid, is 1 to 2. If the moles of HCl is 0.2, what will be the number of moles of this? So that one will be 0.2 times 1 divided by 2. So moles of calcium carbonate will be equal to 0.1. So now we can get the RFM of calcium carbonate. The RFM of calcium carbonate, you add it to, that is, we have been given here calcium is 40, so 40 plus next is carbon 12 plus oxygen is 16 times 3. So this one will give us 100. The RFM is 100. But we know that, how do we are asked to calculate the mass of calcium carbonate that remained. So how do you calculate mass? Mass is equal to moles times RFM. This one is equal to 0.1 times 100. And this one gives us 10 grams. So 10 grams were used up. So how many grams remained? The total was 15. The total was 15. So it means the remaining mass equal to 15 minus 10. So 5 grams remained. 5 grams remained.